will start group 15 elements of B block. In group 15, the elements are nitrogen, phosphorus, arsenic, antimony, and bismuth. These are the members of group 15. We will discuss the properties of these elements one by one. First point is the occurrence. Occurrence means their relative proportion in different form. For example, nitrogen has maximum occurrence followed by phosphorus. In rest of the elements are present only in traces in small amounts. Nitrogen compounds are mainly present as a protein in plants and animals. Apart from this, they are present as ore as well. Phosphorus compounds are mainly present as ore in minerals. In arsenic, antimony, and bismuth, although their relative abundance is very less, but they are mainly present as minerals and ores. This is the abundance of group 15 element. Next important topic is the electronic configuration. Electronic configuration of group 15 elements is NS2, NP3. Here you can see it has completely filled S section in half filled P section. As we know, half filled and fully filled configuration are extra stable. That's why their relative configuration is more stable as compared to group 15 elements. Next is the ionization enthalpy. Ionization enthalpy and atomic energy size are comparatively related. So before discussing the ionization enthalpy, I will discuss atomic and ionic radii. Atomic and ionic radii means their size. Clear? Size regularly increases down the group. There is no exceptional case. But as we move down the group, the increase in size from nitrogen to phosphorus is very large, whereas phosphorus onward size although decreases, but increase in size is very, very small. The factor responsible for this is the size increases because of number of shells increases, but there is one more factor, poor shielding of D and F electron, which will take place in heavier elements. So when we move from nitrogen to phosphorus, size increases significantly, large increase in size occurs, but from phosphorus to arsenic to antimony to bismuth, although size increases, but only small change you will observe, although increase in size is a regular factor. Ionization enthalpy means energy required to remove the electron. It is very easy to remove the electron from larger element, larger size atom. So as size increases regularly on moving down the group, ionization enthalpy decreases. So ionization enthalpy regularly decreases on moving down the group, whereas atomic and ionic size regularly increases on moving down the group. Isn't it? This is the factor. Next is the electronegativity. Electronegativity also depends upon the size. The smaller the size, more is the electronegativity. So electronegativity is maximum for the nitrogen and it is regularly decreases on moving down the road. So there is a regular decrease. It's a good thing that no exceptional case is there. We can easily recall the facts of group 15. These are general information of group 15 element. Next topic is the physical properties. In physical properties, you will find that only nitrogen and phosphorus are non-metals. Arsenic and antimony are metalloids. Whereas bismuth is a metal. So we can say in general metallic character increases down the group. Here this is another physical property of group 15 element. Apart from this, they exhibit allotropy. Allotropy means when an element is present in different forms, different elemental form. The different elemental form of particular element is called allotropic. For example, you will get the phosphorus in different form in nature, like black phosphorus, red phosphorus, white phosphorus. In all these forms, the atom present is only phosphorus, but the way they are attached with each other, that is different. That is the reason why their physical properties are different. This kind of element and elemental form is called allotropic. So this is general characteristics of group 15 element, that they are present as a allotrop. Apart from this, their melting boiling point regularly increases on moving down the group. The size increases, so molecular forces increases, and that is the reason why their boiling point regularly increases on moving down the group. Clear? Next is the chemical properties. Chemical properties are divided in two parts. First is the oxidation state. Chemical properties will be discussed in two different segments. First is the oxidation state. The most common oxidation state of group 15 elements are +3, +5 and -2. Apart from this, they exhibit minus, +1, +4, etc. But most common is +3, +5 and -2. Clear? The maximum oxidation number which can be exhibited by group 15 element is +5. This is the maximum oxidation number of group 15 element, and this is called group oxidation number. Group oxidation number of any of the group of P block is group number -10. Like in group 15 element, group number -10 means 5. This is the maximum oxidation number, and this is called group oxidation number or group oxidation state. Clear? The minus oxidation number is exhibited by the non-metals only. Metal cannot exhibit negative oxidation number. The oxidation number of metals are always positive. If you recall the elements of D block or F block or S block, all the S block element, D block elements and F block elements only exhibit positive oxidation number. None of the element can exhibit negative oxidation number. So exhibiting negative oxidation number is a tendency of non-metals only. So as you know, the non-metallic character regularly decreases down the group. So tendency to exhibit minus oxidation number decreases down the group. Clear? If we compare +3 and +5 oxidation number, +5 is more stable for lighter element like nitrogen, whereas +3 is more stable for bismuth. In this trend of exhibiting two oxidation number less than that of group oxidation number is called inert pair effect. This is called inert pair effect. Inert pair effect means exhibiting two oxidation number less than group oxidation number. Means +5 is more stable for lighter element, whereas +3 is more stable for heavier elements. Clear? And the reason of this inert pair effect is the poor shielding of D and F electrons. As we discussed earlier, in D block, the elements are present as NH2 and P3. Means 2 electrons are there in S section, whereas 3 electrons are there in D section. Clear? And P3. But for the heavier element, like if you take an element having different number of shells, the electronic configuration of the last shell is NH2 and P3. These electrons are attracted more towards the nucleus for the heavier element because intervening electrons are D and F electron, so they exhibit poor shielding effect, and due to poor shielding effect, charge passes easily. And if charge passes easily, then these electrons, these are the S electron which are present in the small orbital. P orbital is comparatively larger. So these two electrons are attracted more towards the nucleus and they remain inert for the bond formation. So only 3 electrons can make the bond for the heavier element. That is why the oxidation number is +3 only. For lighter element, these electrons can get unpaired because the attraction is not more. That is the reason why they can exhibit +5 oxidation number as well. So what is the inert pair effect? This is a phenomena of exhibiting two oxidation number less than group oxidation number, or you can say this is the reluctance of s orbital to make the bond. In the reason of inert pair effect is poor shielding of D and F electrons. Is it clear? Next topic is the anomalous behavior of nitrogen. As we know, the first element of any of the group of P block exhibit different behavior than that of other member as compared to other members of their group. The reason of anomalous behavior are four reasons are there. First is the exceptionally small size. Exceptionally small size. Second is high ionization enthalpy. Third is high electronegativity. And fourth is absence of d orbital. I repeat again. The reason of exceptional behavior, anomalous behavior, is first is
Smaller size.
exceptionally small size. Second, high ionization enthalpy. Third, high electronegativity. And fourth is absence of d orbital. These are the reason of anomalous behavior. Now we discuss the reason. Now we discuss what are the anomalous behavior of due to that reasons. The first anomalous behavior is the maximum covalence. The maximum covalence for nitrogen is 4 only. Clear? Covalence means balancing, means number of bond they can form. As we know, nitrogen has only one s in 3 p orbitals in its valence shell. Total number of orbitals are 4. So maximum they can make 4 bond at a time. Clear? That is called maximum covalence of nitrogen is 4. But for these elements, they have d orbitals also. So they can use their d orbital also for the bond formation. That is the reason their maximum covalence can get beyond 4 and they can exhibit 6 covalence as well. Clear? 6 covalence also. But maximum covalence for nitrogen cannot get beyond 4. Second anomalous behavior is the first element nitrogen can form only p pi bond. P pi bond because they do not have any kind of d orbital, so they cannot form d pi bond, or they cannot form p pi d pi bond due to absence of d orbital. They have only exhibit. They can only make p pi kind of bonding. This is the exclusive behavior, different behavior of nitrogen. One more interesting fact you will find in P block that as we understood the reason very easily that nitrogen cannot form d pi bond or p pi bond because it does not have any kind of d orbital. But one more thing you will get here, these elements, heavier elements, can form only d pi bond or p pi bond. The heavier element other than nitrogen, all the element cannot make p pi bond because if although they have d orbital, nitrogen cannot form this kind of bond because nitrogen does not have d orbital. But these elements, in spite of having p orbital, cannot form p pi bonding because their p orbital is larger in size and this orbital get diffused while overlapping. So the bond formation is not very much effective. So they cannot form p pi bonding. This is the anomalous behavior of group 15 nitrogen, the first member of group 15 element. Next is the chemical properties. In chemical properties, we will find 4 different topics. Clear? Chemical properties, the first point is reactivity. In chemical properties, 2 different topics were there. First is the oxidation state that we discussed earlier. Second part is the reactivity with some different elements. So now we are discussing the reactivity with some different elements. So out of four kind of reactivity, first is reactivity with hydrogen. If these elements combine with hydrogen, they will form the hydrides, a binary compound. Binary compound means in which only two type of elements are present. Out of those two elements, one is the hydrogen. The second, E means any of the member of group 15. In place of E, you can put the symbol of any of the element of group 15. This is the general formula of hydrides. This type of compound where one element is hydrogen is called hydride. So when these elements combine with the hydrogen, they will form hydride. We discuss now some general properties of hydrides. On moving down the group, stability of hydrides decreases. On moving down the group, stability of hydrides decreases. As we know, on moving down the group, size of the element increases. As the size of element increases, bond length increases. In longer bond is always weaker bond, easy to break. So if any kind of these elements, any of these elements will form the bond with hydrogen, this hydrogen bond, the bond length regularly increases on moving down the group. So as the bond length increases, bond becomes weaker. And weaker bond can be broken easily. So they will release hydrogen easily. They are not stable. That is the reason why stability of hydrides decreases on moving down the group. This is the one fact. Second, their basic character decreases down the group. Third is their reducing property increases. Clear? Why reducing property increases? Reducing agent are those which can release hydrogen easily. So, as we discussed in case of thermal stability, their bond length increases on moving down the group, they will increase in size. So, if bond length is more, bond is weaker, can be broken easily. It can release hydrogen easily. So, suppose if we take the example of bismuth can use the hydrogen most easily among all these elements. Clear? So this is the strongest reducing agent. Reducing character regularly increases thermal stability or stability of hydride regularly decreases on moving down. Basic character. All these elements have one lone pair of electron. And in chemistry, the compound which can donate the lone pair is basic in nature. So although lone pair is present on all the elements, but the size of lone, suppose nitrogen, hydrides, NH3 has lone pair of electron. Similarly, phosphorus and hydride also has lone pair of electron, but the size of lone pair increases. As the size of the element increases, size of the atom increases, size of lone pair increases. A small pair of electron can be donated easily because size of that lone pair is compact, which can be donated more easily. If the size of lone pair increases, it is very difficult to donate that lone pair. That is the reason why their basic strength regularly decreases, because size of lone pair increases. So donation of that lone pair becomes more and more difficult on moving down the road. This is all about the reactivity of hydride. Next is the reactivity with oxygen. Oxide. Yes, when they react with oxygen, they will form oxides. Reactivity with oxygen. They will form two different kind of oxides. First is P2O3. The second is E2O5. Oxidation number is written in cross. Oxidation number of element in this oxide. Element is any of the element of
member of 15 group.
Yes. So this is the oxidation number of this plus 3. Oxidation number is plus 5. Clear? These oxides are comparatively more acidic. As the oxidation number of the element increases, their acidic character increases. This is general rule of inorganic chemistry. These are the more acidic. These are comparatively less acidic. One other important rule is there. If we compare the oxides of non-metal, metanoid or metals, the oxides of non-metal are always acidic in nature. So whenever the element in this general formula is nitrogen or phosphorus, its oxides are acidic in nature. Oxides of nitrogen and phosphorus are acidic in nature because this is non-metal. The oxides of arsenic and antimony are amphoteric in nature. Amphoteric means which can react with acid and base both. That is called amphoteric. In oxides of metal is always basic in nature. So oxide of bismuth is basic. Is it clear? Now we discuss the next topic, that is reactivity with halogen. On reacting with halogen, they can form two different kinds of halides. First is PX3 and second is PX5. Clear? Out of these two, it has plus 3 oxidation number, it has plus 5 oxidation number. One question you will find in NCERT that why pentahalides are more covalent than trihalides. Why pentahalides means when EX5 type of halide will form. This is a trihalide, when 3 halogen atoms will attach with the element. So, out of these two kinds of halides, these halides are comparatively more covalent as compared to these hydrides. Clear? The reason behind this, whenever this kind of hydride has to be formed, then it is very difficult to lose 5 electrons for the element. So, what is the easiest way to share the electron? And if bond is formed by the sharing of electron, then it is covalent in nature. But if bond has to form with the 3 halogen atom, then metal can either lose the electron or can share the electron. Both the options are there. So then these halides are either covalent or ionic in nature. Clear? But these halides are always covalent in nature because 5 electrons cannot be lost easily because large energy is required to accompany that process. Clear? So that is the reason why pentahalides are more covalent than trihalides. Next is the reactivity with metals. Whenever any of the element of this group react with the metal, which element can react with the metal which is either non-metallic or metalloid? Metal cannot react with the metal. They can only form the alloy if they are present in different proportion. Okay. So, what is the oxidation? As we discussed earlier, the tendency to exhibit -3 oxidation number. -3 oxidation number is
non-metallic property.
Non-metallic properties. Very good. -3 oxidation number is non-metallic property. Only non-metal can exhibit -3 oxidation number. And this tendency is decreasing down the road because metallic increases. In any of these elements can react. Whenever any of these elements react with the metal, their oxidation number is only -3. So whenever you will get -3 oxidation number, you can understand easily that the element of this group has been reacted with the metal and they have formed certain kind of bonds. Isn't it? So this is all about chemical properties of group 15 element. Next topic we will discuss next time in the next lecture. Thank you very much.